Sorry for the one-day delay, but I ran into a problem. There's always problems, aren't there? I searched up and down and I couldn't find my XR2206, so I ordered another one. It's at the Phoenix post office, should get here tomorrow. This is, what is today? Wednesday, October 1st. The months just fly by. But I found this old audio generator, and this is based on an ICL3083 IC chip. But this thing has a problem. It only goes to 2.4 kilohertz or something like that. But I'll use it here just to demo the audio oscilloscope, and we'll come back tomorrow and scan the amplifier. I added a pot here. This is 10K, but just any high value will do. Put it on the sine output, and I'm going to use the center lead and the ground lead to adjust the amplitude out. The only adjustments this thing comes with is a duty cycle, and you want it at 50% for sine waves, and then there's a distortion adjustment, which allows you to distort the sine wave and see if it's reproduced or whatever through whatever device you're testing. And there's a switch here to go the low range, which goes down to like 20 hertz to 240 hertz, and then the high range goes from 200 hertz to 2.4 kilohertz. The spec sheet on this chip says it should go to 300K. Now I don't know if that's because the kit manufacturer put a wrong value in here, and I'm gonna have to spend some time on it, but not now. I mean, I got other things. We got other things that are more important. We can come back tomorrow with the other thing. But let me go and let me put the ground to the scope, and let me put the output to the input. This is why I use these little test leads and 2.54 millimeter headers, because I don't have to mess around finding a BNC connector with a cable with a couple of clips, and you know. All right, so this is the DSO-138, and I think there are a couple of different models, because I think I saw on AliExpress the other day a model that had a signal generator built in, but I may have been hallucinating. I'll have to go back and check. So 9-volt supply and 2.54, and this thing has a DC barrel. You have to be careful. It says 9 volts. If you feed it 12, I don't think it has a voltage regulator. Plug this in, it comes up, gives you this thing, tells you it's, and then there's some copies. There are some rip-offs because I don't have anything turned on. That's my display. Now you get your waveform. You also get two panels here. One of them shows you the frequency, duty cycle, etc., and Vmax and Vmin, and this shows a Vmax that's got a DC voltage in there from I don't know where. Let me turn on the 12-volt supply to the audio generator. It's drawing 26 mils. I've got the output set to 0. Let's see, let me make sure here. I've got low, low. So let's crank the voltage up, or the output. Okay, I need to adjust the time here, and this thing, there's a select here that'll select between menus. So that went from time to how you want to trigger it, whether you want to trigger on the rising or falling edge. Then I can set my trigger level. Then I think, don't know what that is. Here I can set my 0, so I can move, excuse me, yeah, I set the 0 level, and so I can move it up, and that moves the display, the waveform up and down. So let's go back here to the time scale. That makes it shorter. I want a longer time scale, so it's not triggering. So let me go set the trigger level. Whoops, what'd you do here? That's interesting. Oh, I know what I did. I didn't want 0.2 seconds. I want shorter. There we go, 10 milliseconds, 20 milliseconds. All right. Now, if I adjust my output from my generator over here, the level, and there it shows a max of 1.4 volts. See this level here? And it says Vmin is minus. There's a DC offset for some reason. Frequency is 24 hertz. Cycle is 0.04 seconds. This 20 millisecond scale here, I don't know if you can see it. Let me, I'm gonna mess this up. Let me move it in closer. You can see this vertical scale here. From here to here is 20 milliseconds. So there's a minimum there and a minimum there. So that's 20 plus 20, that's 40 milliseconds, and so that's one cycle. So that's what this shows. Duty is at 49.1, 49.6, and I can adjust the duty cycle over here. Let me see if I can do this by hand without a screwdriver. Okay, that lowers it. Always pick the wrong direction first. Okay, there's the duty cycle. Whoops, I had it. Whoops, it went to 50 because I had my dirty paws on it. There you go. It's close enough. 49.9, 40. It fluctuates back and forth. So let's see if I can undistort this thing if I adjust the distortion knob here. See it get pointy there? May need to go get a screwdriver. Now it's pointy on the bottom side. Somewhere in there is a sine wave or close approximation thereof. That's close enough for government work. And now I can vary the frequency. Goes from 23 up, gets higher and higher. Also note that the amplitude stays pretty constant. Varies a little bit because of triggering. But this thing goes up frequency to 213 hertz. Now let me go high back to the low end of the high scale, and that should be around 200 hertz. Let me change the time here. Okay, 200 hertz, 1.4 is the max. Run it up. Here's around 1 kilohertz, still 1.4. Run it up to the max, and it only goes to 1.9. So 2 kilohertz. That's not going to be good enough to scan our audio thing. But I find this little critter, you can find it for less than $10 on AliExpress. It's usually a kit, but I saw one that was assembled. So you have to do, you know, like going through a random pile of stuff. You're going to have to do a lengthy search and rescue on AliExpress to find the cheapest one, and you can find one built if you don't want to mess with it. But it's a cute little thing to have around. So I just wanted to show that, explain what the delay is, and we'll get back to it tomorrow, and we'll get on with stuff. I could waste my time and go from 200 to 2 kilohertz, and I got another project I need to get done this afternoon for somebody in California, and I'll be back tomorrow. Thank you for your time. Again, some likes, and we'll just show you test equipment as we go along. Thank you.